Guys, today's video is on the discriminant. The discriminant does is it tells you how many solutions you're going to have in a quadratic equation, and specifically what type of solutions they will be. Formula for the discriminant is b squared minus 4ac. This looks familiar because it's inside the square root sign of the quadratic formula, so you don't need to memorize any other formula besides quadratic formula because the discriminant is in it. Once you find what the discriminant number is by doing b squared minus 4ac, you could get a positive number, you could get 0, or you could get a negative number. If you get a positive number, and that positive number is a perfect square like 16 or 25 or 100, you're going to have two roots. That means you're going to have two different solutions, and they're both going to be rational numbers. If you get a positive number, that's not a perfect square. You're still going to have two different solutions, two different roots, but they're going to end up being irrational. That means they're going to have that square root sign and with the plus minus and all that stuff. If you do the discriminant and you get 0, you're going to have one answer, and it's going to be rational. If you do the discriminant and you get a negative number, less than 0, you're going to have two solutions, two roots, but they're both going to be imaginary numbers. Two examples. I'm going to write the discriminant formula on the side here. B squared minus 4ac. So a, b, c. B squared is 12 squared minus 4 times a times c. Here we get 144 minus negative 104. That turns into a plus. So that equals 248. 248, not a perfect square. So you're going to have two solutions, two roots, and they're going to be irrational. Again, we're just like previewing and predicting what's going to happen when we solve for these quadratics. Number 4, here a is 0, or excuse me, a is 3. There is no b, so b is 0, and then c is 24. C is your constant. Plugging this into the discriminant formula, we get 0 squared minus 4 times a times c. So we have 0 minus 288, which is negative 288. Since my discriminant's negative, you're going to have two roots, and they're both going to be imaginary. What we're going to talk about next is that since we've learned several ways on how to solve quadratics, we're going to talk about when is it best to use each method when we have a quiz or test, just to save some time and to work more efficiently. Learned how to solve quadratics through graphing. That's when on the coordinate plane you look at the graph and you see the 2 points where the x-intercepts are, and those are your solutions. So you can sometimes do graphing. It's best to sometimes use it, not all the time. It's best when your solutions end up being integers. Because let's say you looked at the x-axis and they weren't perfect, they were kind of in between two integers, you would have to do that trace zeros and left bound, right bound stuff, and that's a little trickier. So it's easiest to use graphing when looking at the table when your solutions are integers. It's best to do the factoring method. Sometimes it's best when solutions end up being rational. If you could factor a quadratic, so for example, if you have x squared minus 6x plus 9, that could be factored into x minus 3, x minus 3. So if you can factor it, go ahead and factor it. Again, not all quadratics will be factorable. We didn't necessarily go into the square root method that much. It's an okay method. It can be used sometimes. I'll show you real quick what it is. It's used when there's no b value, so like no x b value. So on the side over here, let's say we have 2x squared minus 10 equals 0. So what you're going to do to both sides, since there's no x term, you would add 10. So we're left with 2x squared equals 10. Divide by 2. And then take the square root of both sides. So we get x to equal the plus minus square root of 5. That's the square root method. When there's no x term, then you can just solve for x using just a normal equation method, and don't forget the plus minus when you take the square root. The next one is called completing the square. We did a lot of that. You can also do it sometimes. It's best used when your b value is even, because if it's not even, you're going to have to take half of b and square it and add it to both sides. And then if it's not even, taking half of a number that's odd, you're going to get a fraction. It's just a headache to do that. So complete the square when b is even. And I would probably look to graph or factor first before I get to completing the square quadratic formula. So if I can't factor it, and if the answers aren't integers, that's when I would go to completing the square quadratic formula. Because quadratic formula, you can always do it anytime. And it's easiest when all others fail. And by all others, I mean these: graphing, factoring, square roots, and completing the square. I would try to do quadratic formula last because it takes a little bit longer, and there's a lot more ways to mess up in the quadratic formula with negative signs and not simplifying properly. So try to graph, try to factor. Think about doing square roots or completing the square before quadratic formula. But if you love it and you're great at it, you can always do it. On the back of the notes is just some practice for you to find the discriminant of each and to solve each using a specific method of either factoring, square roots, completing the square, or quadratic formula. What I want you to try to do is do a couple of these, find the discriminant, think about what method you would probably use to solve these, either by factoring, graphing, completing their quadratic formula. And we'll talk about this in class, just which method you would use and which would work and which wouldn't work. Have a great night, guys. See everyone next time.